Hi, my name is Nigel Day and I'm Product Manager for Polyhedra, ENIR's family of relational database systems. I would like to show you a quick demo of a feature that's added in Polyhedra 9.0, which was released in June 2015. The kit I'm using for the demo has 4 Raspberry Pi computers, each fitted with a small graphics card, and I've set it up so that if I press a button on the card, the Polyhedra database server on that computer is killed. The computers are connected together via an Ethernet hub, and the whole kit is powered by a USB battery bank. The 2 computers on the left are working together to provide a fault-tolerant Polyhedra database service. When I press the special button on one of them to kill the local Polyhedra server, the server on the other board is immediately promoted to master. When a new Polyhedra server is started on the failed board, it will be set up as standby, so that, in turn, it can take over if the server on the other board fails. Failover also occurs if a board dies. If we now concentrate on the top right-hand board, what you can see is a dynamic trend diagram, showing how the values reported by 2 onboard temperature sensors are changing over time. The trend diagram is generated by a Python application, which is querying a local Polyhedra database. And there is a separate application that is pumping the latest values from the sensors into the database. The Polyhedra Historian module has been configured to capture time-stamped samples once a second and log them away for use in the trend diagrams. So far, the features I have described have been in the product for years and help make Polyhedra very well suited for use in, for example, industrial control systems and SCADA applications. What Polyhedra 9.0 added is a partial replication mechanism that allows any database to subscribe to selected tables in other databases, so you can keep a live cache. For this demo, I configured the main fault-tolerant database, running on the left-hand boards, to connect to the database running on the top right-hand board, and to set up a subscription so it can get information about the sensor readings. Which brings us to the 4th board in our demo kit, the one on the lower right. This is running the same Python application as that running on the board above it, except that this time it is querying the historian in the main fault-tolerant database. The only reason that the graphs are the same as on the upper board is because the new subscription feature is keeping the main fault-tolerant database service up to date. I can easily show the setup is as described by unplugging the Ethernet cable from the board on the top right. Its trend diagram will continue showing new readings as they are recorded, but the one on the lower screen has an ever-widening gap on the right-hand side. Once I plug the Ethernet cable back in, though, the central database can re-establish the subscription and catch up on the missing readings, and these will quickly become available to the trend diagram on the lower board, showing that everything is back in step. This new partial replication feature is configured and controlled simply by creating records in the database that wants to cache information from the other databases. There is no need for special coding. This makes it easier for multiple databases on separate systems to work together, allowing systems to scale more easily. For more information about this new feature and for some use cases, please visit the website developer.polyhedra.com.